Welcome to Superheroes of Science. I'm Steven.
And I'm Sarah. We co-host Science from the Experts. Our guests are professionals doing cutting-edge science right now.
They're experts in their field discussing what they know best. So listen up and learn real science from real people.
Subscribe now and stay informed of our latest episodes and show your support.
Joining us today on Purdue Superheroes of Science, we are here with Brad Garczynski. Brad is a fourth-year PhD student here in the Department of Earth, Atmospheric, and Planetary Sciences at Purdue University. So thank you so much for joining us.
Yeah, thanks for having me.
Yeah.
So start with what do you research?
Yeah.
Let's start there.
So as Sarah said, I'm a fourth-year PhD student, and I'm in the Planetary Science group here at Purdue.
Okay.
And in particular, I study the geology of Mars.
Oh.
And I do that using a variety of data sets. I use images from satellites that are orbiting Mars. I use data coming back from Mars rovers, including the Perseverance rover. Mm-hmm. And I also study environments here on Earth to try to understand what environments might have looked like billions of years ago on the surface of Mars. So.
Now I know with the Perseverance rover, that's a really big thing for you, and it was. I remember the launch party and all that, and you're pretty excited about that. Why?
Yeah, well, so I've just to give a little background, I've had the privilege of working with the Perseverance rover since starting here at Purdue.
Okay.
My advisor is Dr. Bryony Horgan, and she's a co-investigator on the science team, and so through her I've been able to get involved, which has been a really incredible opportunity and an incredible learning experience to be a part of that. So I started here in 2018, and that was a few years before the rover landed. And to give a little bit more context, the Perseverance rover is one of the most recent Mars rovers to land on the surface of Mars, sent by NASA. And it's about the size of a small car. And back in 2012, NASA landed a very similar rover on the surface, the Curiosity rover. And each rover, since Perseverance, has had a simple question that it's been trying to answer. The first rovers, the Mars exploration rovers, had a question, well, did water exist? Did liquid water exist on the surface of Mars? And the answer to that question was yes. And then Curiosity...
Wait, liquid water was on Mars?
At one point in time. Yeah.
At one point, okay.
Right
now there's no liquid
Not
water?
today. The atmosphere is too thin.
Okay.
Okay.
So, and then Curiosity wanted to understand, well, did liquid water last long enough on the surface of Mars to create habitable environments for life to exist? And the answer to that question was yes. And Perseverance has been tasked with this even more profound question, well, if we have a habitable environment, did life exist there at one point in time? And so I've had the privilege of being a part of that team to try to answer those questions. And like you said, I've been involved from early on, before they even selected a landing site, and to now to actually be doing operations on the surface of Mars. So it's been a long journey, but it's been fun.
So if one of these driving questions is, would life have existed, or would there have been a potential for life to exist on Mars? What sorts of evidence do you go about, how do you go about answering that question?
Yeah, that's a great question, and things that we're trying to understand on the surface of Mars as well is, we only have one data set to work off of in terms of life, and that's life on Earth.
Yeah.
And we know life obviously requires water, and probably long enough, water to exist long enough to sustain life. It requires energy gradients. So we're looking for particular pieces of evidence that would indicate that. So we look at rocks. Did rocks interact with water at one point in its history? How long did they interact with water? What type of chemicals may have existed there that may have supported life? Or we're looking for organics, evidence of organics, which the presence of organics doesn't necessarily mean that life existed, but it can, and that's a good indication that.
But isn't that like the definition of organic? Something that was living?
Well, you could get. Well, our definition of life is it's carbon-based life.
Okay.
So organics can be associated with life. but not necessarily. You could have non-biologic forms of organics in the solar system. So that's one good indication. And so these are the types of things that we're trying to understand more. And one of the incredible things about the Perseverance rover is that we actually have an opportunity to sample some of these rocks.
Okay.
And NASA hopes to one day send another mission to the surface of Mars, a robotic mission, and to bring those samples back to Earth. And the reason that's so important is because we have an incredible sophisticated instrument suite on the surface of Mars, but the best science you're going to do is back here on Earth with much larger laboratories, much more sophisticated instruments.
Yeah.
Because you don't have to fit everything onto a car and then launch it hundreds of millions of miles away. You have the luxury of having these big research facilities. So that's the hope. Is what we're trying to do on the surface of Mars is find the best possible samples to bring back and have future scientists analyze those samples and try to find evidence of life and learn more about the history of Mars.
Why? Why do we? Because there's a lot of money we throw at this, right?
Yeah.
I mean, these missions aren't cheap. It's not like filling up your car and driving down the road. So why do we want to know this?
That's a good question. Why? And the reason is because Mars presents an incredible opportunity not only learn about the history of Mars, but also learn about the history of our planet here. Mm-hmm. And so our planet is about 4.6 billion years old. And a large part of that history is recorded within our rocks. But a large part of that early history has been wiped out. And we have processes on Earth that Mars hasn't experienced. That's tectonics, like plate tectonics, where we're subducting plates and basically recycling those rocks back into the Earth, and we're erasing that record. We have weather, and we have rain that erodes those rocks away and deletes that record. Mars has a pristine surface that hasn't experienced any of those processes. So early on, it has a record of some of the oldest rocks in the solar system that may record a story of that, not only the early solar system, but what Earth might have been experiencing at that same time. And we have good indication that early on, Mars and Earth were very similar in terms of they both had liquid water. They both may have had a similar atmosphere.
Okay.
At some point, they diverged, but we have an opportunity to access some of those oldest rocks and learn more about our planet. And going out beyond science and understanding the history of Earth, it's a technological feat. It's an opportunity for us to push the boundaries of what we're capable of doing. Mm-hmm. And one of the things that the Perseverance rover, the larger Mars 2020 mission, has been able to do is they've sent the Ingenuity helicopter, which is it's not a science instrument. It's been a technology demonstration, and it's the question of can we fly an aircraft on another planet? And this was the first powered flight on another planet beyond Earth, and it was a unique challenge because Mars's atmosphere is about 100 times thinner than ours.
Okay.
And so you have to spin the blades really fast. So we didn't know if we could do that, and the helicopter was given 5 flights. And it's done an incredible job, and it did so well that NASA even extended the mission. So now most recently, I think, did its 23rd flight or 22nd flight. Yeah. Wow. So it's stuff like that is presenting these unique challenges that push the boundaries of what we're able to do in terms of technology that we can then apply back here on Earth.
So the helicopter that it's flying is it like getting images, or is it doing scans? Because I know they're not going to fly it just to say, oh, we did.
Yeah.
I'm sure they multi-purpose everything.
Yeah. So also to give you some context, it's not a giant helicopter with some Martian just flying around. It's about like 19 inches tall. Okay. So it's pretty decent sized little drone.
Yeah. And
it was, when NASA sent it there, it was tucked up in the belly of the rover. And one of our first jobs when we got to the surface, in addition to checking out all the instruments, making sure the rover was safe, was finding a good safe, we call it parking spot, to deploy the helicopter. And the helicopter just folded out of, and just the Perseverance dropped it off, and then Perseverance drove away and was able to actually record video of the helicopter in flight. And to answer your question, early on, the first 5 flights were just to see can the rover or can the helicopter get off the surface and do all these maneuvers. And after those first 5 flights, NASA wanted to see, well, how can we use the helicopter to prioritize science and help a rover mission on the surface of Mars. So it's sort of been a scout for the Perseverance rover, where it does reconnaissance on areas that the rover can't reach, or the areas that the rover is going is planning on driving to. So it takes images in flight, and actually on its recent flight, it did a really cool flight where it took images of the descent stage of the Perseverance rover that had the parachute on it, and that the rover ejected, and actually it crashed into the surface. So you could see the remnants of the descent stage, which is really cool. That's the first time we've ever really been able to take images of that quality of a piece of hardware. So yeah.
Are you guys like building transformers then? Is that what's happening here?
We're building transformers.
Yeah, like Decepticons. I mean,
I don't know. Maybe the next mission. I don't know.
I get a little nervous here.
Thoughts on the surface of Mars.
Oh my goodness.
Unfortunately, Curiosity and Perseverance are too far away for that, but I don't know if that's in NASA's budget.
Thought I'd ask. I just throw it out there.
Yeah. So it'd be cool. It'd be, a moneymaker if NASA's trying to get more money.
Oh,
Yes, it would.
Go into entertainment.
wow.
But
So, what in particular what do you spend your days researching?
yeah, so so the team is made up of hundreds of scientists and engineers, and we operate it on a daily basis. So we have an engineering team at the Jet Propulsion Laboratory, which is where the mission is based out of, and we have a set of scientists there, but most of the science team is sort of scattered all around, and we each bring to the table different set of expertise and research backgrounds. So we have people who study volcanic processes. We have people that study deltas and river systems. We have people that study astrobiology and look at understand how microbes interact with rocks. So everyone has a different particular area of research and interests. For me, my particular research interests are, currently I'm using data from the rover to understand these particular features that we're seeing on the surface of rocks that are these coatings, these rock coatings that we think formed in the presence of water. They have certain minerals that are suggested that there was some sort of water that interacted with these. So trying to understand more about how these coatings may have formed adds another piece to that larger puzzle or story that of the larger history of that crater. We know there was a lake there at some point in time, but what happened after that lake or during that lake is a huge question mark, and that's what we're trying to answer.
Yeah. Now, if I remember right, when we talked to Bryony there over a year ago, if the team suspects there's a possibility that there is life somewhere, you're not allowed to land there.
So
the
existing
Planetary
life,
Protection,
there's a huge
Planetary Protection Act or something like that.
Yeah, there's a huge set of or offices of NASA that is devoted to planetary protection, and that's sort of if we find if we go to a place that has existing life, then there are a lot of rules and things that we need to abide by to make sure that we don't want to contaminate anything that that may be existing on Mars. So what the Perseverance rover is doing is tasked with finding ancient life. We don't suspect that existing life is there because the surface environment of Mars is really harsh today.
Yeah.
There's really high radiation. There's no liquid water at the surface. It's pretty barren. There's a set of research that is looking into the subsurface of Mars as a potential place for life to exist, but that's an environment that we can't access with the rover.
Okay.
Or currently with the rover, but yeah. So there are certain areas of Mars that have higher potential than others, and those are areas that we have to be careful because we don't know what exists there,
Yeah.
and we don't want to contaminate anything or do any
Discover life on some sort of life on another planet and wipe it out all in the same action.
Yeah.
Oh my gosh.
Yeah. So
That'd be a little irresponsible.
yeah, probably.
Well, this is your current. This is research right now. It's currently your current research. What is like in the future? So at some point, will you be able to continue this research? Will there be an endpoint for you that someone else would pick up on? How does that?
Yeah. So, I mean, as a PhD student, for better or for worse, my days here are numbered. So so when I leave here at Purdue, I hope to continue at some point with the rover, but that would be sort of outside of Purdue.
Oh, okay.
And then, but my advisor, Dr. Horgan, she's a co-investigator, so she's on the mission, and she'll probably bring in more students, and she's, I think, bringing in a postdoc, and that will be working on the mission.
Okay.
So she's she has a group that, and some of her other students she was a participating scientist on the Curiosity rover, so she has some
cool.
students that have been involved with that, but she's most active on the Perseverance rover.
Now, correct me if my assumption's wrong, but you've spent years. You've dedicated years and unbelievable amounts of hours researching this and investigating this, and so I would assume the project wouldn't want to lose that expertise. And so if you get a job, I assume you're going to be, I don't know, do you plan on being a faculty somewhere or a research scientist somewhere?
That's a good question. I think the immediate goal is I'd love to stay on the mission in some capacity.
Yeah.
I think, like you said, is being involved for so long and to have that sort of knowledge set. And there's certain days where, I know a few years from now we're heading to this part of the crater. We're actually going to the outside of the crater.
Yeah.
I'm like, man, I just want to see what's over there.
Yeah.
And,
Yeah, right.
so I just want to stick around long enough to look at that other side of that that landscape. I think that's the immediate goal. Obviously, with anything, it's moving on to other things or bringing in new people. That's important. It's important for change. It's important to get new perspectives. So recognizing that too is that's the only way I think that the mission could be successful, but also the individuals on the team could be successful, is getting different perspectives. So I'd love to stay in some capacity, but I think long term I'd love to be in some sort of teaching capacity, and I'd love to stay around science. But we'll see. Maybe I'll look at this YouTube video a decade from now and be like, man, I don't know what
I
was
had no idea where I was going. After a decade or two, we're always wondering. We always look back, right? Huh? But so that's just part of life. As someone who's lived a few decades, I can tell you.
Yeah.
But I just didn't know if this was preparing you to be a research faculty at a university somewhere, or is it more preparing you to be a NASA researcher or something like that? I just didn't know which, or is it really preparing you for either one?
I guess both to some extent.
Okay.
So it's definitely helped me understand it's forced me to become a better researcher, I think. And so it's definitely helped me as a research scientist.
How has it helped you?
Well, as an early career to work with these hundreds of scientists that are well established, and and some of the most brilliant scientists that are working on the surface of Mars, and people have dedicated their entire careers. So it's in a sense you're sort of and it's an incredibly welcoming community and supportive community to be part of. But it also holds you to higher standard too, because you're working with data from the surface of Mars, and that's valuable data, and to get the most science out of that mission and to make it worthwhile, you need to be efficient and making use of that data and making those interpretations. So it's been an opportunity for me to put myself out there and to really work with that data and present it to a larger team that has an incredible amount of experience that is able to critique that, to offer thoughts and to even better my science that I wasn't able to do before. So it's been a really cool opportunity to work with these pretty established people.
Well, you're a humble person, and some of what you're saying is a little deceptive the way you say it, because it's not just a learning thing for you. You're an active scientist. You are a scientist participating in this. It's not like you're just here because some of the way you say some of the things, it's like, oh yeah, I'm learning, I'm getting so much knowledge from this, but you're giving knowledge to this. You are a contributing member of this.
Yeah, I'd like to think so.
But the way you say it sometimes, it doesn't come across that way. But don't undersell, because I know for a fact you are. I mean, I've heard Bryony speak nothing about your contributions and how smart and how great you are and how nice you are and all of this. Yeah. And so I know for a fact the scientists involved value the input and the science that you are doing because you are a member of that.
Totally, and that goes back to what I said about one of the things that is so awesome about being part of it is that the community is really welcoming, and that those scientists really value the contributions from the more early career people. And so yeah, it has been a cool experience for me to have an impact on a mission, to be on operations and say, hey, you think Perseverance give 15 minutes of its time to look at that rock over there? It'd be really great for my research project. So that's a bizarre experience to be like, hey, I really think
you've done that.
Yeah, I've been offered, or I've offered input into observations.
Yeah. Now, how do you interact with all these other scientists? Is this just some big old email thread?
Oh my gosh, I didn't even think about that.
That would be an incredibly inefficient process.
Yeah, right. Yeah. Trying to go back and see, like, wait a minute, did I respond?
Dear NASA, can you look at this?
Please.
No, so most of it is virtual. So it's mostly on WebEx or so these telecons that we call into. So we have the daily operations. Well, early on we were working 7 days a week. I mean, not individually. We would have shifts.
Yeah.
But now we've gone to a 5-day work week where on Friday we'll send up a few days worth of work for the rover to get through the weekend. But so when you're on shift, you log into a telecon and you're on the telecon with a bunch of engineers and scientists who are also working that day, and you're either responsible for planning the rover's day for that coming day, or there's another telecon worth of people that are planning the next few days, so the day after tomorrow, and the few days after that, there's another group that is working on getting the data down from the previous day and analyzing that. And then each instrument has their own teams that are working on their individual data and processing that. So it's a pretty extensive process, and it's this sort of really integrated collaboration from scientists and engineers from all over the world. And we have international collaborations. We have teams in France, in Spain, and all over. So everyone's in different time zones. But, and then a few times a week, the entire science team gets together and looks over data and talks science and stuff like that. So
what kind of clearance? You have some special clearance thing then?
I had to
Is there a
fill
name
out some
for it?
paperwork.
Is there a name for your
early
clearance
on.
level? He's not telling us. There's a name.
I know.
There it is. He's just not telling us.
I don't.
It's classified.
There's a lot of
Okay.
paperwork involved. I honestly I could not answer that, but yeah, because it's a government agency. There's certain things. It helps as a U.S. citizen. It's a little bit easier than some of our international colleagues.
Yeah, they have a few more hoops, don't they?
Yeah, but yeah.
Very neat. Wow.
That is awesome.
Yeah.
All right, probably the last question. You said we study Earth to understand what's happening, the processes that are happening on Mars. So what have you studied on Earth?
What have I studied on Earth?
Yeah.
So beyond looking at coatings on the surface of Mars, I also have another area of research that I've been focusing on, and this was sort of goes back to early on when I first started at Purdue, was looking at environments on Earth and to understand what the landing site of Mars, Jezero Crater, which we haven't talked about in much detail, but Jezero was, we have strong evidence that Jezero hosted a lake, a deep lake environment about anywhere between 3.5 to 3.8 billion years ago. It has this incredible large delta that we could see from orbit. And now that we're on the surface, we could see we're actually up right now. We're actually right up on the front of the delta, looking towards it, and it's got a valley network, and it's got minerals that formed in the presence of water. So we know there was a deep lake there, but before we got there, the only thing we do, one of the productive things to do is to use the laboratory we have access to here on Earth, and that's the natural environment here, is to understand lakes that might have been similar to what Jezero was like 3.5 billion years ago. So I studied a particular lake in Turkey called Lake Salda. So back in 2019, Brian and I went there, and we worked with some colleagues at the local university there in Istanbul, and we're studying these particular rocks called carbonates. And these carbonates, they form they form in the presence of microbes. So microbes usually help those rocks form, and it's they precipitate out of a solution that's really alkaline. It has really high pH. So the chemistry and the geology, the surrounding geology of that lake is similar to what we're seeing on Jezero. So the question that I'm trying to answer is, how can we use this lake to better understand how particular rocks, like we see evidence of carbonates on the surface of Mars, or at least from orbit we have strong signatures of carbonate. How may have those carbonates formed? Did they form in the presence of microbes? Did microbes help those rocks form? And there are other ways carbonates could form that don't include biology, but that's one possibility, and that's what we're trying to understand more about. So
you study the rocks and the chemistry of Earth to understand what happened in another planet millions of miles away.
Yeah.
So what are you? Are you a environmental scientist, a chemist, a geologist, a planetary guy? What are you?
I guess it all falls under geology. Geologist. Yeah. I definitely wear, within the larger field of geology, I try to wear a few different hats. I think that's just how the trajectory of my PhD has gone, is trying to learn a little bit more about carbonates and how they form, and then I put on a different hat and learn about a totally different thing. And Yeah, I think that's one thing about being geologists and being a good scientist is broadening your expertise.
Yeah.
Absolutely.
So learning more about geochemistry and stuff like that, and learning more about interactions with rocks and microbes and stuff like that. So, yeah.
But and these are the same things that I mean. I was talking to Dan Chavez. He's like, "Well, you have so many questions, you have to narrow and decide which one." And so that's how you get expertise. I mean, it sounds like this is the rest of your life.
Yeah,
I guess this is exactly what you do.
Yeah.
And that's cool. That's cool that you're not only figuring out our planet, but you're helping figure out the universe.
Yeah.
Well, that's a lot of responsibility all of a sudden.
Yeah, I guess so. So.
Well, thank you. We
Yes,
appreciate
thank
you
you so
taking
much.
time.
Thank you for listening to this episode of Science from the Experts from Purdue University Superheroes of Science.
If you like this episode, subscribe, give us a positive review, and share the love. Boiler up!
Hammer down.